How do instantaneous and average power differ in AC circuits? Imagine you're watching a wave at the beach. Sometimes the wave is high, sometimes low. The same idea applies to power in an AC circuit. Let's explore how these two types of power work together. Instantaneous power is the power at any exact moment in time. It is calculated by multiplying the voltage and current at that very instant. Since both voltage and current in AC circuits are sinusoidal, their product changes constantly. This means the instantaneous power rises and falls rapidly, sometimes even becoming negative. When it is negative, it indicates power flowing back to the source, especially when reactive elements like inductors or capacitors are involved. This fluctuation happens at twice the frequency of the voltage or current wave. Think of it like a roller coaster ride that goes up and down quickly. Average power, on the other hand, is the mean value of the instantaneous power over one complete cycle. Because the positive and negative parts of the power wave cancel out over time, the average power gives a steady measure of the energy actually delivered to the load. To find it, engineers use the root mean square values of voltage and current, along with the cosine of the phase angle between them. This phase angle tells us how much the current is shifted relative to the voltage. The formula for average power is the RMS voltage times the RMS current times the cosine of that phase angle. This value is what we usually call real power or active power, and it represents the useful energy transferred per second. The key difference is that instantaneous power shows us the real-time energy flow at any moment, which can be positive or negative. It helps us understand peak demands and transient behaviors. Average power smooths out these fluctuations and tells us how much energy is actually being used over time. In practical terms, average power is what we pay for and what components are rated for. Instantaneous power analysis is useful for understanding system stresses and designing protection devices. Reactive elements like inductors and capacitors cause the phase difference, leading to reactive power, which does not do any network but affects the total current and system efficiency. To sum up, instantaneous power is very dynamic and shows the immediate interaction of voltage and current. Average power is a steady measure of the energy delivered over time. Both are important in analyzing AC circuits, with average power being the main figure for energy consumption and system performance. Understanding these differences helps engineers design safer, more efficient electrical systems that work smoothly and reliably.